Trigonometric ratios, the inverse. So inverse operations are operations that reverse the effect of the original operation. So when we look at addition, the inverse operation is subtraction. So x plus 5 and minus 5, these will cancel out, so we're left with x. Then, the operation multiplication, the inverse operation is division. So if we have x multiplied by 5, then divided by 5, those cancel out, and we're just left with x. When you square something, the inverse operation is to take the square root. So taking the square root of x squared, those will cancel out, and we're left with x. So now as we move into the trig functions, sine, the inverse operation, is just the inverse of sine. It looks like an exponent of -1, but this is the notation for the inverse of sine. So when you have sine inverse of sine, those will cancel out and you're left with x. So likewise, for cosine, you have inverse of cosine. So these will cancel out and you're left with x. Tangent, and then tangent inverse, these will cancel out and you're left with x. So when we're looking at our trigonometric inverses, we are using these to find the acute angle measures in a right triangle. So here we have our right triangle ABC, and we're going to talk about how to find the measure of angle A. So you're going to start by setting up your equation the same way we did when we talked about trig inverses. You take the angle you're looking at, label your opposite, hypotenuse, and adjacent, and then you're going to use your acronym Sohcahtoa to help you set up the equation. So the sine of angle A is equal to the opposite side, x, over the hypotenuse, c. But if you're trying to look for the measure of angle A, then to solve for the measure of angle A, we need to get rid of this sine. And remember, this is not sine multiplied by A. This is the sine of angle A. It's a different operation in and of itself. So to cancel out the sine, we need to take the sine inverse of both sides. So then on the left side, only that angle A remains. And then when you take the sine inverse of x over z, that will give you the measure of angle A. And the other two trig functions follow as well. If you set up the cosine of angle A is the adjacent over the hypotenuse, and if you take the cosine inverse of both sides, then you can find the measure of angle A. And again, the same idea for tangent. Tangent of A equals the opposite over adjacent. So if you want to find the measure of angle A, take the tangent inverse of both sides. So why don't we go ahead and put this in practice with an actual problem. So this question is asking us to find the measures of the unknown angle and round all answers to the nearest tenth. So I'm going to start out by writing our acronym Sohcahtoa, because this is going to help us choose the right trig function for each problem. So when we look at this first one, let's go ahead and label, and we'll start off just like in the last video. Here's our angle that we're looking for. 9 is the opposite side, and across from the right angle, 10 is going to be our hypotenuse. So we have information for the opposite and the hypotenuse. So the trig function using opposite and hypotenuse is going to be sine. So we'll set up the sine of angle x is equal to the opposite side over the hypotenuse. Now, this time, the variable we're looking for is the angle measure. So we need to get rid of the sine. So again, remember, this is not sine multiplied by x, it's the sine of angle x. So to cancel out sine, we need to take the sine inverse of both sides. Now I'm going to write it up here because I don't really have space in there. Now the sine inverse and sine will cancel out and you're left with just x. And on the right side, we have the sine inverse of 9 over 10. Now to find what that actually is equal to, we're going to take out our calculator. And remember, in the graphing calculator, just make sure to double check the mode. It should be in degree mode Radians is a different angle measure, and it's going to give you all of the incorrect answers even if you type in the correct things into your calculator. So my calculator's in degree mode, so let's go ahead and type this in. Above the sine, cosine, and tangent buttons on your calculator, you'll see in blue the sine with that notation inverse, cosine inverse, and tangent inverse. So we're going to hit that second button and the sine, and then you get that inverse sine button. 9 divided by 10. I'm going to close my parentheses and hit enter. So it is going to give you a decimal, and that's fine. So our answer, the measure of angle X, is going to be 64.2 degrees. So since X represents the entire angle measure, but it is technically a variable, for this one, 64.2, you don't have to put the degree symbol after it. But if your notation asks for the measure of an angle, then you definitely want to put the degree symbol after that. Let's go ahead and look at the next question. So in this diagram, our variable is up here in this angle. So let's go ahead and label. This would be the opposite side, and then 12 is going to be our hypotenuse, which means 11 needs to be our adjacent side. So the trig function that uses the adjacent side and hypotenuse is going to be cosine. So we'll set up cosine of the angle is going to be equal to the adjacent side over the hypotenuse. So again, we're in this situation where we're looking for the angle measure, and we need to get rid of this cosine. So we're going to take the cosine inverse of both sides so that these guys cancel out. We're left with x is equal to the cosine inverse of 11 over 12. And then, of course, we're going to go to our calculator for this last step. Press second, the cosine button, and then type in 11 divided by 12, close your parentheses, and hit enter. So x is going to be equal to 23.6 degrees. Now for this next problem, I want you to go ahead and pause, try it on your own, and check back with me when you're finished. Hopefully when you labeled your triangle, you needed to use the opposite and adjacent side, so you set up tangent of x is equal to 12 over 29, then took the tangent inverse of both sides, and then when you put the tangent inverse of 12 over 29 in the calculator, you should have gotten x is equal to 22.5. That's it for this lesson on trig inverses. I'll see you in class for more practice.